video, we're going to go over what the fundamental counting principle is. So it says there in your box that E1 and E2 can be two independent events. So your E is going to stand for the events that you guys have. The first event, E1, can occur in so many different ways. So M is the number of ways, and E is your events. So the second event, E2, can occur in M2 ways. So the number of ways that that the two events can occur is M1 times M2. So you multiply the number of ways together. Okay, so let's look at the first example. It says that a radio station call letters consist of 4 letters beginning with either a K or a W. Okay, so call letters are just the letters that a radio station comes up with, so like WOX or XRY, or I'm trying to think of any local, but I'm not coming up with any off the top of my head. But that's all that call letters are. It's just those letters for the radio station. So it asks how many different radio station call letters are possible if letters can be repeated. So it says the radio station call letters consist of 4 letters. So we need 4 spaces. And we're going to multiply each one of those together. So it says if the letters can be repeated. So the first letter, that first space, is a K or a W. So that's going to be 2 different ways that we could, or 2 different possibilities in that spot that we could have. Now what about the second, third, and fourth letter? It says they can be repeated. So that one is going to have any 26 of the letters. We can use K again, we can use W again, but we can also use any of the other 24 letters. So 26. So we're going to end up with 2 times 26 times 26 times 26 for the number of ways and the number of different radio station call letters that are possible if you are allowed to repeat them. So when you multiply those together, you get 35,152 ways. So now what if it says how many different radio station call letters are possible if letters cannot be repeated? So you're still using the 4 letters. And K or W is still going to be one of the first 2 letters. But if we can't repeat letters, guys, then that means that if we use a K or W, we've used one of those letters. So if there's 26 in the alphabet, we're now only left with 25 to choose from. Now you use a K or a W and one other letter. Now we're down to 24 letters to use. After we use that third letter, we're down to 23 choices to choose from for the 4th letter. So once you guys multiply those all together, you end up with 27,600 possibilities to write those call letters for the radio station. Okay, so number 2, I'm going to do letter I with you guys, the first example, and then you guys are going to do the second example. It says determine how many different computer passwords are possible for A, if the digits and letters can be repeated, and B, if the digits and letters can't be repeated. So first we need to know how many letters and digits are possible for us to choose from. Well, we know that there are 26 letters in the alphabet to choose from, but what about your digits? Digits are the following. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 1 through 9, and your 0 is going to give you 10 total for the digits you guys can use. So, it wants to know, okay, digits and letters can be repeated and digits and letters can't be repeated. So, if we look at our first example, it says 4 digits followed by 2 letters. So we're going to have 6 total spots. So this is A, where they can be repeated. So 6 total spots. And the first 4 are digits. Okay, so we have 10 total digits. We can repeat them, so we have 10 to choose from each time. And the second 2, it says 2 letters. So we can choose from any of the 26 letters for both spots. And we multiply all 6 of those values together. And you get 6,000 or 6,000,000. 676,000 possible passwords. Okay, so then what about B? If the digit and letter could not be repeated, so we still have 6 places, 6 numbers or letters that we need, but for the 4 digits, we can't repeat them anymore. So we have 10 to choose from for the first number. Once we've used one of them, we now have 9 to choose from, then 8 to choose from, then 7 to choose from. Okay, the letters, how many letters we had to choose from the very first time? 26, but once we chose one of those letters, we had 25 for the second letter. Go ahead and multiply this all together, and you come up with 3,276,000 possible passwords. So, I want you guys to try and do that second example. It's just like the one we just did. And then also try to do number 3.